Well, hello and welcome to this presentation. My name is David Carlos from Victoria Air Photos and Survey. And today in this presentation, we're going to try to show you the enormous benefit that using modern drones on RPAS equipped with thermal imaging can help with roof and building inspections and analysis. And one thing we note about the imagery that we take with the drone is that there are thermal and RGB images that are shot kind of side by side. As you can see, that we can couple it with both the thermal imager and the RGB. It's critical to compare both so that if we see errors or things that are superficial, we can disregard them on the RGB imagery. And this can help reduce false readings or recordings. This also allows us, with the 48 megapixel camera, we can do a really good visual inspection for analytics at the same time, or see any obvious defects that stand out. The other advantage of the side-by-side camera is it allows better understanding of the existing light conditions at the time of the inspection, and including cloud conditions. Thermal imaging using drones is non-invasive, it's very safe, and risks no damage to the roof structure. As we know, standing on a roof structure is not only unsafe, but it can also damage roof tiles and displace things, making any notable damage even worse. And these inspections may be done by day or night. The ambient air temperature was about 5 degrees Celsius, and there's a good shot of the dual action camera. That's a 48 megapixel RGB camera with a 1/2 inch sensor. So this was a complex residential apartment, and an example of the footage that was taken side by side. And on this mission, we really lucked out because we were able to find a roof that was actually being repaired and the membrane being replaced. This section here is the new membrane on it, and then this is the old. And as we fly the RPAS in, we can get a closer look at it, and we'll hover and begin to do our thermal shoot on about a 45-degree angle. So here again is just highlighting the old roof versus the new. So there's the old structure and there is the new roof structure. So now we'll switch over to the thermal, and that's what the thermal would look like. And so immediately we look at this area and we can note some specific areas of interest. Right there is the barrier of the new roof. Obviously very apparent right there. That section is all new. And there's some of the tools that we've seen laying around there and some of the roofing materials. But immediately we see some emissivity right in that area there that goes down there, and then all around that. And so we could assume very quickly that that is actually water ingress in the membrane of the roof structure. Over there, it's even more pronounced. These are kinds of the things that stick out, and we notice this edge here is has a lot of emissivity showing. And you compare it with this side. See, on this edge, I don't have a lot over here on the new part, but over here on the old one, I can see lots of thermal anomalies. And same with the seams. If you can see the seams right in here, running along in here, you'll see an emissivity there, showing that water is beginning to get in. And again, compare it with here. We can see the seams, but nowhere near as much thermal loading as these ones up here. So this is just a really good benefit that we had to be able to highlight some areas of interest, a lot around some of these vents. That vent there is probably an exhaust fan. That's where that emissivity is coming from. This was equal thermal loads on this structure all day. It was really in the same position. So we don't have a discrepancy there. So lots of activity. You would look at something like that and say that is suspect. And again, comparing it with the old roof, we can see some water pooling here and no water pooling here. And this was after, by the way, a big rain shower. And so you can begin to compare the RGB image with the thermal. A lot of thermal loading on this section right here. But when we go to the RGB, there's nothing that really stands out there, is there? That's an example of where the thermal imagery is valuable. Right there, visually, it looks okay. But if I go to the thermal, I can see a lot of thermal loading in there, indicating the presence of water. Another application we can have is to inspect for heat loss signatures or insulation deficiencies. And that's an example of the rooftop of a building, heat loss coming out of the windows here. We can see this roof looks pretty good. This, by the way, was taken well after sunset, within basically night hours. We can also monitor for cold and hot gas leaks and or exhaust defects. And so this again was taken in pitch black, and we can see the gas was very apparent. So that just shows the value of using drones thermal imagery for inspecting gas, for gas leaks or defects. And at VAP we use only commercial drones that are capable and designed for commercial purposes and for professional use. And with that, it gives you a cutting edge technology. For example, the RTK unit here is something that gives you better positioning, and that's something we want to make sure is correct when doing any kind of inspection work or survey analysis. And just the whole drone itself is designed for commercial use. There's safety features built into this so that you can avoid other aircraft and not be a conflict to air traffic in busy control zones and so forth. And then, having done the imagery, we do have tools for data analysis reports, which we can forward to the end user, which talks about the environment and the image, and then just gives a report and some of your numbers right here. And there again is just the comparison, a really good comparison analysis of basically almost half of a roof structure that had been repaired versus one that had not. So in conclusion, these new methods of building inspections should definitely be considered by stratas, by building managers, by those who are involved with roof inspection or building inspection. And I would argue that they do not replace a conventional roof inspection by any means. They will certainly help determine it if there are premature problems that are existing in the envelope or the building, and or if a costly building inspection or an engineering report is warranted. So you send up one of these drones on a roof that you're worried about, and then you're checking for thermal anomalies on it. At that point, you can escalate it for a building inspection or a engineer to get involved with it in concerning a remediation. So this is really good, because if you can take preventative measures on roofs or structures, it can really save in the long run and detect problematic areas. So this could be part of a monitoring program that you have periodically throughout the year, and especially after heavy rain. Drones we have been flying since 2013 without incident. They are safe and efficient, non-destructive testing methods for inspection, and can easily access difficult to reach areas to provide valuable data. This is what we do. We're professionals at it, and so we desire to employ this technology for the betterment of the community. Drones are much better than conventional handheld infrared equipment, simply because they can get into the best position and close to video. And please feel free to contact us for any of these qualitative inspection reports. We're willing to work with our partners and collaborate with individuals who want to employ or test this technology to arrange an appointment where we can get the drones working for you. So thanks for watching, and please call us today.